Hello everyone, welcome back to Untitled Engineering. Today we are doing Centroids, Engineering Science and 4. A centroid is at the point... Hello everyone, welcome back to Untitled Engineering. Today we are doing Centroid, Engineering Science and 4. A centroid is being defined as the point at which the object balances. That will be the center of the object. This it's a square. We know that the center of a square will be somewhere here. And how do we get the center of a square? We can say draw a line from this corner to this corner, draw another line from this corner to this corner. Where they intersect, that will be the center of the object. We can also say if this is our h, let's say this is our width, the center will be h divided by 2, and then it will also be y divided by 2. The dimension that we are going to get here will measure the half of h will be here, and measure the half of y will be here, and then draw a straight line like this, draw a straight line like this. Where they intersect, that will be the center of the object, that is at the centroid. So when we are dealing with centroid, we know in a Cartesian plate, this is our x and this is our y. We are going to say this being the square, we are going to call this part will be our y bar. And then our y bar is given by what? Our h divided by 2. And then we are going to say our x bar, this part will be given by what? Y divided by 2. And then when we represent, we will say our centroid is equals to x bar, y bar. We are giving, we want the coordinate of where exactly is the centroid located. So if you have your y bar, you have your x bar. This is x bar. You can just point from this point, mark that y bar, x bar rather, and mark that y bar. Draw straight lines. Where they intersect, that will be your centroid. So let's look at the centroid of a square. So let's look at the centroid of a rectangle triangle. You can tell that looking at the shape of the right angle triangle, you can tell that we cannot just say if this is our x, this is our bar. We can't just say our centroid. Let's say this is h and this is b. We cannot say our y bar it's equals to h divided by 2 and our x bar it's equals to b divided by 2 as well, because if you do that, we're going to say our b will be somewhere here, our y will be somewhere here. Draw straight lines, they will intersect here. According to the drawing, looking at the drawing, you can tell that this cannot be the center of this object. So these two, they are not correct. We have a formula to calculate. We have a formula to calculate for the centroid of a right angle triangle. The center of a right angle triangle is actually located at 1/3 of the height from the bottom and 1/3 of the breadth from this point, meaning it will be somewhere here and here. We draw straight lines. Where they intersect, that will be your centroid, meaning your x bar will be given by, this is h, this is your b, your x bar, and this is your h. Your y, your x bar will be given by 1/3 of the breadth, and then your y bar will be given by 1/3 of your h, which will give you the coordinate of the centroid as x bar and y bar, which will be located somewhere here. So if we are dealing with a rectangle is something like this. From here we can also tell if this is B, this is L. We can say our x bar is equals to what? L divided by 2. And our y bar is equals to what? B divided by 2. Because we can tell that the centroid will be at this center. Meaning we can just do that other method that we did, draw a line from this point to from this corner to this corner, from this corner to this corner. That will be your centroid. So this one you can say the length divided by 2, the breadth divided by 2. That will give you your centroid, the coordinate of your centroid. These are standard structures. We can easily get their centroid. It becomes a problem when you are now having two standard structures that are combined together. Something like this. You can tell that from here we can do like this. We have the right angle triangle and the rectangle. So now we are asked to calculate what for the centroid of this object. What we are going to do as our first step is to divide these two into two shapes, and then we say this is number 1 and this it's number 2. In this case, we are going to use a formula to calculate for the centroid of this object. A formula that says our x bar is given by x number 1 times area number 1 divided by let's say plus x2 times area number 2 divided by the total area, which is area 1 plus area number 2. This will be like this. Let's give this simple dimensions. Let's say this is 9, and then let's say this is 19. From here to here it's 19 meters. Then from here to here is 9. Let's exclude this. This is 9. Let's say the x bar for number 1. That's what we want first. And then the x bar for number 2. Then we're going to say area number 1, area number 2. Let's say this is 3. This is 9 from here to here. The overall is 19. From here to here it's 9. From there to there it's also 9. And then we are going to say our x bar, we are only considering what? The rectangle. Our x bar, which is this side, we know is x and y. Our x bar is this. It will be what? Since this is 9, meaning from here to here it is 10. Our x bar will be that 10 divided by 2, which will give us what? Will give us 10 divided by 2 is 5. That is our x1 for this object labeled number 1. And then we also need our y1 and y2. And then our y1 will be in this. It will be 9 divided by 2, which will give us what? 4.5. And then we go to the second structure. The second structure, every dimension that you are taking, you are going to take it from this line. This is the line of reference. Also, this is the line of reference. What do I mean by that? This we know. Let's take it out like this. We know the dimensions of this structure. Here it's 9, here it's 9. And we said the centroid of this particular structure, it will be 1/3 from this, from the bottom, 1/3 from this line as well. Meaning it will be like this. 9, our x will be 9 times 1/3, which will give us what? 369. But now this is from here to here. We need to take everything from this point, meaning it will be from this point we include the 10, which is from here to here, and then from here, that is when we are going to include that 3, which is from here to here. Everything, every dimension that you are taking, you are going to take it from this line and from this line, meaning it will be 3. Yes, we know that if we are only considering this structure, but now we are taking this as one structure, meaning every direction, every dimension that we have to take it from this point. It will be that 3 plus the 10 from this point, which will be the rectangle, meaning here we are going to have our x being equals to 13. And then we go to the y. The y, it will be 3 because this is where our reference line is. It will be 3. And then our area, we know our area here will be area number 1, 9 times 10, which will give us 90. And then here it will be 1 half height times breadth. It will be 9 times 9. Which will give us 4 times 5. And then from there, we are going to substitute everything. X1 is 5 times area 1 is 90 plus X2 it's 13 times area 2 is 40.5. The total area, it will be 90 plus 40.5, which will give us our x bar as 7.4 7.483. And then this is our x bar. We also want what? Our y bar. Same procedure, just now we are going to replace the x with the y. It will be y1 times area 1 plus y2 times area 2, the total area, and then we substitute. Y1 4.5. Area number 1, it's 90. We go to y2, it's 3. Area number 2 is 40.5. What's this? 4.5. 40.5. Okay. And then the total area, it will be 90 times 40.5, which will give us our value is 4.0345. And then our centroid, we are going to say G is equals to Let me write it here. G is equals to x bar y bar, which will be, what is our x bar? Our x bar is 7.483. Y bar is 4.0345. And then we come to the structure. Let's draw the structure, redraw it.